Hey! Hello and welcome to another Solana tutorial. Today is the third episode of the security module. Yes, talking about program security again, my favorite topic. That's why I'm so excited. I've had my brain run on 100% utilization for the past hour to come up with a great example, or at least what I think will be a great example, for the thing that we're gonna talk about today, which I will not name yet because I want you to not be preoccupied with ideas of what could be the problem here. I want you to just think about it because I want you to be able to spot those things in the wild. That's why I'm making those videos, to train you on, hey, this is a thing that can go wrong. I do need a title for that video though. Something flashy for the thumbnail as well. So let's call this one Double Trouble. Yeah, that's ambiguous enough that it doesn't really mean much and still hints on what we're gonna exploit today. Double trouble. But that's all that you get out of me until we get to the solution. So, is there anything else that I need to say in this little intro? I think no, it was a bit rushed, admittedly. I just sat down and let's go. But yeah, let's go. So, let's jump down here. We're gonna work on our SEC again, our favorite program, because it's so secure. And we're gonna change it up completely to do something completely different. I checked out a new branch, Double Trouble, because that should also not give everything away. Double Trouble, let's get started. I'm so motivated, it's crazy. Probably not for long, because I'm gonna do anchor development and my motivation for stuff will decrease. Anyway, so we did a bunch of stuff in the last episode. We're just gonna remove this and we're gonna do what is our program actually gonna do? Init player, and we're gonna do play. I don't know. So we're gonna develop a game where two people play against each other, and it's gonna just be a game of chance, like rock, paper, scissors, or like throwing a coin, something like that. It's all gonna be done in one transaction, and there will be one winner and one loser, and we go from there. You'll see me develop this as I go, but yeah. What we need for that is some kind of player accounts. So essentially there will be one type of account and it's gonna be a player account. The player account will of course store a player, which is just the pub key of the player. We can store the bump, yes, why not? We're gonna store wins or points or something like that. Points, I don't know. Let's call it points. We'll need to take care of overflow and underflow, but that's a user's problem if they get too many points. And then I'm gonna also store their lucky number, their last guess. That's just gonna be a byte. We're just gonna compare bytes. Although, let's compare U32s. So that's inside the player account. That sounds about right. And so a player account gotta do sign up the system program, and the player account will be of type player account, and the player is the payer for people with reading difficulties. This is amazing. Space 8 plus 32 plus 1 plus 4 plus 4, and then this will be the player, and we take the player key in there such that every player has exactly one player account. That makes sense, I judge. And the init literally just sets up this account and says okay, because it's like all in there. The system program will do the account initialization, and all we gotta do, we will store the bump, the player, set points to 0. Let's go player.key bump to, I never remember that. Get for the player account, set the points to 0 and also the lucky number. It's gonna be 0 anyway when we initialize it, but might as well make that obvious here. That's just the init. That's gonna persist that into my account, and that's good. Let's see if that builds. Let's let that build while we continue. So for the play then, we're gonna use play accounts. what's gonna happen now is that there will be two players, player 1 and player 2. Each of those players will have their own player account. Player 1, player 2. And they will obviously have the same seeds, except we will not initialize them. That ain't happening. So seeds is player 1 key, and bump is player 1 account bump. Since we so neatly already stored that, might as well use that. And of course the same thing for player 2, except with a 2 and a 2. Now we do not need a system program. Do we need anything else? Just 2 player accounts and the 2 players. We might need something else for my pseudo randomness to determine the winner. I actually don't know how I'm gonna do that yet. I did that in the game of death. Oof, which challenge was that? Okay, let's do some magic such that we get random numbers on chain. There is no random, but we're just gonna use slot hashes. They are as random as it gets. I mean, they're hashes. That's pretty much random. You can't really fake them. So it's a good source for randomness. There's still attack vectors on that, but I promise you, our attack today is not dependent on those random numbers. You can't just assume that the random number generator that I use actually produces random numbers. It doesn't really matter. I'll quickly hack something to get myself some pseudo random numbers, but that's not the important part of this video. Give me a second. Oh shit, it didn't compile. I gotta unwrap this. Thank you for suggesting this. Okay, that builds. Amazing. So back to my pseudo randomness. Check. Because I don't know how to get the sysvar in here, I just use an unchecked account. Again, this is not the attack vector that I want you to think about. This is just to quickly get some get some random numbers. Okay, I give myself like 10 more minutes. If I then don't manage to get this whole thing to build again, I'll throw out and just one. Yes, it builds. Nice. Basically what this thing is doing is first it checks that it has the right account because we neglected to do that here. Then it gets the data from that account, which essentially holds the recent slot hashes. And then we take hash number 1, because why not? Then we calculate the offset to this one. And a slot hash has 32 bytes, like a public key. So we can grab a random number from somewhere between, 0 and 32. Actually, I'm gonna grab 2 random numbers now. Random number 1 and random number 2. It really doesn't matter. I can do 10 to 14 and then 14 or 16 to 20. It doesn't matter. 4 bytes. I just need 4 bytes for a U32. And then we put them in here. Okay, does it build? Consider borrowing. Okay, I borrow. Rust error messages are pretty helpful with this help. Yes! Compiles. Does it actually work though? No idea. We would need to test that. So did we actually do that locally or did we do that on devnet? We did localnet. Okay, let's stay on local then. Then I need my Solana test validator. And I'll just hope that I can just anchor deploy. Cool. Deploy success. Cool. That's how I like it. Now I need to actually, call stuff on that. For that, we need some scripts, some run scripts. Init player, the system program, and the player account, which actually I think I have seeds on, so you can auto-derive that. You'll be fine. Let's initialize that. And actually, just for fun, let's set up this player account. Oh, come on. Node not found. Can I just run it from a Windows terminal? What kind of transaction is it trying to build? An instruction with data that is too large. Lol, what? What is happening here? What is going on here? Ah! Help! I need somebody. Not just anybody. Help! I need someone's help. Somebody who knows Anchor, maybe? It's always other stuff that is like It's not the thing that I'm actually talking about that is my problem. It's random shit. What data are you trying to put in that transaction? This is a weird error, must admit. This is... What? And again, we're not even looking at the thing that I actually want to look in this video yet. It's all like so much other stuff. Ah! Come on, you can do it. Yeah, okay. So, we get that transaction through if we do nothing, aka call an instruction that just says let's chill and okay, then that's fine. So there seems to be something with those init accounts that just is wrong. So let's read through the entire thing. If you see the error, then you're smarter than me. What is the error? Open my calculator, please. Just open it. I just need you to start the calculator. I'm going Donald Trump on you. Fuck you! Now it's 4 calculators that started. 49. Okay. Round it up. Make it 50. Nah, make it 69 because maybe I made a mistake somewhere in the calculation. Deploy that. Maybe you don't like a calculation up here. Maybe it's that. I don't know. I'm willing to try anything right now. Anything to make it work. Just make it work. I mean, I'm forgetting the thing that I actually wanted to do because I have to struggle with this. And that's always the same. I always struggle with some other random stuff. Not the stuff that I actually want to work on. I don't get it. Solana development is so freaking frustrating. I can't make progress here. Because I don't see where the error is. My transaction has a huge size and I don't figure out why. This is the 3rd day now that I'm trying to make a video about something and always something comes in between and I don't manage to finish a video. Sometimes I hate my job. No, I love my job, but this is stupid. And this is really not even the thing that I want to, like, talk about here. No. Fuck me. This can't be so difficult. Why is this so difficult? It doesn't seem like this transaction is too big in any way. But here's the thing, though. The do nothing is called. It's the system program create account instruction probably that has this instruction with data that is too large. Something is going horribly wrong here. You know what? Let's deploy to devnet. Fuck you! Can't work like this. See, I told you, my good mood is gonna, as soon as I start developing. Love being a dev. It's the best thing working in Web3. Great. It's therefore gonna be the better if it actually works. The easiest thing, like that's Anchor 101. Initializing an account, I don't manage. I just don't manage. It's not possible for me to initialize an account. I want to flip my table, but it's too big. Maybe I just have such an old version of Solana test validator that the system program has changed. But does the system program ever change? Maybe something has changed. And it's the same thing on devnet. Instruction path to inner instruction is too large. What? This is ridiculous. This is just stupid. Come on. You're just messing with me. And it's been another hour and I don't manage. Nah. Please, somebody help me. Can someone explain what I'm doing wrong? Yes, please. Found this resolution. I was using Solana 1.6. Okay, it's a version thing again. Again, no. You can't. That's why we can't have good things. That's why we can't have good things. Here we go. You just need to find that number. Then you find something on Stack Exchange. So, found the resolution. I was using Solana 1.16.0, which was causing the issue. I downgraded to 1.14.18 and it solved the problem. And I have the feeling that if I downgrade, it will cause other problems. It's so frustrating. The thing that works one day just stops working 3 days later. And then you have to spend hours trying to fix that stuff. Solana devs are highly underpaid. That's useless. I cannot change the version here. I can't go to 18 because then other stuff doesn't work. I'm bound to this version, and with this version apparently... this is so frustrating. I give up. For the 3rd day in a row, I give up making my video. I can't figure it out. I mean, what can I do? I can't, like, fuck. Ask for help. Yeah, okay, fuck. I will. It's only gray and then the point is to green. Let's see if we reach a breakpoint here or if everything compiles. Alright, I guess we're gonna install an old Solana version on CLI as well. Something is gonna work. I tell you, something is gonna work. I'm gonna get this to work today before I go to sleep. I updated this yesterday to get SPL to work, and now I need to downgrade it again. This is so... And I bet something else doesn't work with this then. It's so annoying. Ooh! Finished! Look at that. We were able to build it. Ah, local. So nice and fast. Deploy success. Test script. What the what? Okay, hey, it works. I just had to spend several hours trying out different versions of Anchor. This is what I have now. I used this configuration now that somebody suggested to me on Twitter. Thank you very much, sir, John. I mean, we don't need those, but it's working now, so I'm gonna leave it as it is. I'm not touching any of those dependencies because it finally works. It finally works. I can create an account. Wow. This is almost sad, but I'm gonna cut most of this out anyway. I'm gonna give you a little bit of my struggle, just so you don't feel so bad if you are struggling a lot with Anchor or Solana development, because yeah, it's still chewing glass. It's getting better, but it's still chewing glass. Ugh. But well, here we are. We have an Anchor program that can initialize an account. Wow. Amazing. Cool. So, fuck me. Now that that's working, to the interesting part. Random 1, random 2. Let's see if that builds. Oh, why do you need to compile bubblegum again? Oh, that's so annoying. Okay, I'm gonna remove bubblegum and SPL compression because I definitely don't need that. There we go, much faster. And it even went through. Ha! Let's do the same setup with a different key. So now it's the second. Now we don't have a do nothing anymore. We need to init player, but that's the same thing. So let's go. I'm gonna get this to work today, I'll tell you. Wonderful. We have the G1 as the PDA. This is our signature. We created an account. And now comes the fun part. We're now gonna call the play instruction. What do you need? You need player 1. Can do that. Wallet is from key pair 1. And key pair 2. So player 1 is key pair 1. Public. Player 2 is key pair 2. Public key. In the actual game, it's the front end's job to, you know, get those keys in one transaction. Could work with like a Solana Pay, some backend signs half of that transaction, and then the wallet signs the second, and then you have the two signers, because they need to both sign, and that also needs to be somewhat quickly because block hashes expire and stuff. But that's nothing that we worry about right now. We just assume that the front end manages to get both of the signatures of both of the players into our transaction, like we do here. Maybe it's just our game that holds all the keys anyway, or whatever it is, but that's just our setup. Don't question it. So we have two signatures. No, we have two players. Signatures are coming, don't you worry. Then we have the player 1 account, which is auto-derived. I'm not even going to provide it, lol. But what we do need to provide is this syswa slot hashes account, and that lives at slot hashes pub key. Amazing. I take that one. And then we do need to sign though with key pair 2 because key pair 1 is in the wallet and that will already sign, I think. Forget that. And we just RPC this here. Okay. I guess that looks okay. Scratchy head. Let's see if that would run. TS node test. Just testing our pseudo randomness. Da 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 da. Fuck. A seeds constraint was violated. Player 2 account. Why? Player 1, player 2. Oh, because we provide the bump, and when we created it in the first row, we did it with a do nothing and we didn't write the bump in there. So one way to do this is to do an init if needed, but I don't like that. So we're just gonna use another account. Yeah, why not? Let's use this one. We have the second and the A end, which is the first, because A is first, obviously. Come on. Who doesn't understand that? Yeah. Got another PDA. And then, let's test. Didn't save that file. Try again. And now, hopefully, we don't have a seeds violation because the bump will be correct. I could also let it derive the bump. But we've stored it in there, so let's use it. Come on. Come on. You can do it. Yeah! Giga! Giga! 3 giga! That's how excited I am about this transaction going through because Solana confirmed this. Check it out, check it out. Yeah, it takes a while, but check this out. We have in our logs, let's play using hash from this slot. Yes, because our validator is currently running at 44.2. We missed the 42. I'm sorry, because it just all took forever. That's the slot hash. And then I calculated some pseudo random numbers. Those two. And if I would do that again now, I would get different pseudo random numbers. Wanna see? We always have to wait a while, but I like this. My pseudo number generator is working. Now, again, as I said, this is not like the safest way to get random numbers. If you really rely on the random numbers, then I'd do it differently. There is no random really. Do it off-chain, use an oracle, I don't know. But as I also mentioned, this is not the attack vector that I want you to think about. The random numbers are just... We can treat them as if they're actual random numbers. This is just my quick hack how to get random numbers. The actual exploit will be different. Just saying. But we need some kind of randomness. So yeah, there we go. We have completely different random numbers. Sweet. This is good. This means that my randomness is working and that my program is finally working. So after 4 hours of setup, we can finally get to the thing that we wanted to do all along. Get ourselves in double trouble. Double trouble. Yeah. Okay. So how are we gonna get ourselves in trouble? Well, first of all, I have to implement the thing that is gonna get us in trouble eventually. Potentially. Doesn't need to. Only if a good hacker understands what to do. And you, my students, might be this good hacker. So pay attention to what we're gonna do now. Oh yeah, I'm good. Now that it's finally compiling, I'm in a good mood again. Welcome back, Andy. Thank you. So those are the accounts that we have. I'm a bit tired already, must admit. It's also past 1, but we'll get there. We'll get there. We push this through. Let's play. So we have 2 random numbers. And essentially now our game is player 1 is playing against player 2, and both of them are assigned a random number, and the one with the higher random number wins the game. Pretty simple, eh? And since it's all done on chain in one transaction, you can't really like front run it or I mean, you can do something after that instruction and check states there and then mess with it. Yes, that's still an attack hack. And that's actually also a very good hack. One of my favorites. But not topic of today. Because obviously both of the players need to sign, and they will only sign if they believe the game is fair. So let's make it a fair game. We just assign the random numbers. Each of the players get their lucky number. And then we compare. If the player 1 has the larger number, and yes, it is a bit unfair because the larger is not larger equals, so there is a 1 in 2 to the power of 32 more likelihood for player 1, but we neglect that. Numbers are big enough that it's pretty much 50-50. We compare that against the value for the other guy, and if that is bigger, then it's a player 1 win. What happens when the player wins? Well, he gets points, I guess. And what happens to the other guy? Well, he loses points. To raise the stakes, actually, maybe let's do the following. The winning player gets all the points from player 2 plus 1 additional, because if they both have 0, then they won't ever get points. But yeah, so basically the winning player steals the points from the losing player plus gets 1, and the losing player just has 0. So I am going to assign the winner. Let's see if I can do this. Let's see if my Rust is good enough. Let's try it. Winner and loser. Wow, if this works. This is an if that returns me something. I kind of like Rust. Oh, hey, sorry. Let. Okay. Oh, okay. Yes, of course. But here we can't return this. I love Rust. It's so, the thing with the returning if you don't have a semicolon. There was a lot of red. Oh, I named them differently. Oh, that's my bad. That's just stupid. It's player 1 account and player 2 account. Oh, okay. My bad, and I can do that everywhere, damn it. And now, move occurs. Ay. Can I just use a reference here? Come on. Ow! Hit the mic. But yes! Ow. Too much excitement about the compiling program can really hurt. At least it compiles. Okay. Now I'm getting excited and sleep deprived. Deprived is the word, you idiot. Okay, anyway, we have a winner and a loser. Both of them are player info references now, which makes the following code easier. We just calculate the points. Let winner points be the loser's points plus 1, because we said they get at least 1 if the loser has 0. The loser gets 0, as we said. So loser dot points now has none, you loser, and the winner gets them all. Clean code, safe code. Hint. I could have written that code differently, and then the exploit would not work as neatly. But, hint over. I mean, this is safe code, right? I mean, we just calculate the points first, and then we set it to 0, because obviously we can't first set it to 0 and then calculate the loser. I mean, how else would you do this? It's just, I mean, this is good code. Does that still compile my great code? All good. So, my program, I think, is complete. Let's test it. Maybe do some logging. Player 1-1. Player 2-2. No. Player 2 lost. Player 2-1. Okay. Let's also log the winning points just to see. So, let's actually play that game. What a great game. Let's play it. Winner is a reference, so the data it refers to cannot be borrowed as mutable. Well, motherfucker. You shall become a mutable reference. Is that a thing? Can you mutate that now, please? Yes, you can. Perfect. Now we deploy and then we play that game. We have 2 accounts. We have 2 players. They're both signing. Let's play that game. Actually, what would be really nice right now is if I would stream the logs. How did that go? Logs. And really, since on my validator there's nothing else happening, I can just stream all logs, right? I can just Solana logs. Because the alternative is to always look at it like this, you know, Solana confirm this one. And then I see the logs here. Let's play this hash. And we have this number and this number. It looks like this one is bigger. So player 2 has 1. And now he has 1 point. Great. If he plays that again, the same 2 players. And now I'm gonna check here. That's the same signature. Player 1 has 1 now. Cool. And the winning points... why are the winning points 1? Shit, something is not working. Hold on, I have a logic error here anyway. First of all, the winner should, if the winner already had points, the points should just be added, right? I mean, that should also be, yeah. But even so, it's a bit weird. Now we see the program being compiled, being deployed. Let the people play. There we go, 2A, Okay, so player 2 has 1 and player 2 has 1 point. Next round. Yeah, it's not persisting that. Now player 1 has 1 and player 1 has 1 point. But player 2 has 0. What am I doing wrong here though? But it's safe, like, it has it in here. Something is not working as I expected to. But that's good, because then I can learn stuff, because I might have wrong assumptions. Let's play, and we see player 1 points and player 2 points in the very beginning as well. I don't want to wait so long all the time. I'm gonna let you play a few times. What? Because it's always using the same block hash. The transaction doesn't change, and so we don't play several rounds, but it's one. Yeah. Anyway, so in this one round, yeah, it starts with 0. Why? So this 1 point doesn't seem to be persisted. I thought I don't have to deal with any of that persistent stuff in Anchor anymore. Wait, are they not mutable? I didn't make those accounts mutable. Of course you can't persist stuff into not mutable accounts, but it's weird that it would even allow me that, to write that there. But then, yeah, I mean, temporarily it changes. Maybe my game mechanic is a bit unfair anyway. You shouldn't be able to steal that many points from another player. But you still should get a few, because the more points the opponent has, the better. So let's change that a little bit and be like, you get 100 points for winning, but you only get a quarter of the loser points. That's more fair, I think. Because otherwise, a guy with many points would just never want to play again, right? I'm thinking a lot about my game mechanics here. I think this is better. Anyway, the real issue here is we need to make them mutable. Okay, deploy again. Build and deploy again. This is a beginner's mistake. I just didn't make them mutable. Good. I'm just gonna put that here and ignore it. The only reason I want to have it is such that in here I can say around And then I'm gonna do a nice, just so something changes. Oh, just so something changes in the transaction such that not this thing happens anymore, but I get different signatures. And then they actually are sent and confirmed. Because I don't want to always have to wait for TypeScript to load. I want you to play several rounds and then we see how the points develop with our new point system. I'm having fun now. If stuff is working, I'm having fun in Solana development. If I need to deal with dependencies, then I hate it. There we go. Now we get different signatures. Amazing. I love it. Let's play 0-0. Player 2 has won, so player 2 has 100 points. In the next round, player 2 has 100 points. Yes! Mutable. Should I make that a bit bigger for you? And then player 2 won again, so he adds 100 points. He has 200 now. Perfect. Starts with 200. This game is rigged. Only player 2 is winning. What the hell? Oh man. Wait, because we're using the same block hash, are we? Wait, using this slot and using, yeah. Okay. Okay. Fair enough, my randomness is shit. I admit, that's on me. It's very rigged for player 2 here. Oh man. Yeah, my randomness is not so random if we don't change the slot. Okay, so I guess we will wait a bit. You freaking win. I'm just gonna manually call it now. That's the fair way anyway. We're just gonna do one at a time again. Fine. Player 2 has a bit of a head start now, which was a bit unfair. Not gonna do that again, but if the randomness was actually random, this would be a fair game. And player 2 is gonna lose now anyway. Nope, winning again. But at least we have different values. And since 3/4 of the points are lost as soon as player 1 wins again. What? This game is so rigged. Okay, one more. If player 1 doesn't win now, then I believe it is freaking rigged. But okay, it was just 3 in a row. 3 coin flips in a row, that can still happen. But now, I tell you, now player 1 is gonna win. Yes, finally, player 1 has actually won. He has gotten 1/4 of those points, which are 200, plus another 100, so that's 300. And player 2 has lost them all. Yes. My point is, with this setup, why I just give 1/4 points, that like in the casino, the more you play, the more you actually lose. So they're gonna just keep trading points, and you know, whenever they lose, they get down to 0. So in order to really make points, you need to have a long winning streak. See, now player 2 won again, and he's just at 175. So to really win at this game and get a high score, you need to have consecutive wins. That's the goal here. And that's also what the hacker wants to achieve. And now, my dear students, we finally come to the fun part for you. Given my program, and given all we know about it, you need to have consecutive wins. How can you go about that? Right? If player 2 keeps winning, he keeps making points. But as soon as he loses, he's down to 0. And even if you place the same guy again, that guy also just has little points. Because he just gets 1/4. It's so fun. I love this game. I thought of a great game. This is a good game. I like that game. Because the casino always wins. And I'm the freaking casino. I could make them pay for every time they play. Yeah, I would have my fun with that. Now, can you hack that? I don't know. Maybe the goal is to get to 1,000 points. So you need to win like 10 times in a row. Maybe then you unlock something. Or there is a high score and the top player wins something. Right? Because I, as the casino, I can make a prize to incentivize players to play this game. By the way, casinos are actually a thing that people gamble on in this space. But anyway, then there are also people who try to hack those casinos. Like you. You gonna totally hack my casino. You have the code. I'm gonna actually, great point. Cool. So Double Trouble is committed. You can go check out the code. You also see the code right here. This is the functionality. We assume that getRandom is actually random, so you don't want to hack this, even though you can, as we saw. But what you do want to hack is this part. So this is the relevant parts, and of course, this is the relevant parts. Here, we want to find a way to have consecutive wins. Remember, we want to win 10 times in a row, or as many times in a row as we possibly can. I would argue I implemented my casino so well that you cannot do that. And I might be wrong. In fact, I am. But I am confident that you cannot hack this. And again, at this point in the video, I'm just talking and talking for you to think. And I would recommend that you pause the video and actually try and figure it out. Because that's the funny part. That's the challenge. That's what you live for as a hacker. Getting a challenge to hack this. Which is not easy this time, admittedly. At least it's not so obvious. But maybe you get there. So pause the video, download the source code from Git, try it out. By the way, a quick side note, I changed a little bit in our code, just in case you're confused when you check it out on Git. I now split the play instruction into a play and evaluate function. So basically I did the evaluation in a separate instruction, but I call them in the same transaction. So it doesn't change anything at all. Just so you know that, so you're not confused. And I don't provide any hints as to how that is relevant for our our non-exploitable program. Yeah, because we're a great casino. Can only recommend, come to our casino. Yes, play in our casino. Here's another message from future Andy. I'm gonna put that version of the program that I just showed you on devnet, the exploitable one. It's under this program ID. Find it below as well. Just if you want to actually do the hack yourself. It's not that difficult. Try it. So, cool. Okay, back. All you need to do is create a front-end script. You don't need a program or anything. It's just this sort of stuff that you need to do. How do you need to call it such that you always win? I'm already giving you hints here. I'm gonna give you more hints until you finally get it. We didn't do a certain check, and we worked with the assumption that that's the case. Do you already get it? Or is that just me? I'm so excited about those things. It's ridiculous. I love that. Can you explain it to me? Go explain it to me. Come on. Yeah? And then? And why does that work? Nice. I think you got it. But I'm gonna explain to the entire class now what the issue here is. So we are, as you correctly said, working with the assumption that player 1, this player 1, is actually a different player than this player 2. Which they don't need to be. I can plug in the same signer here, which results in what? Well, same signer here means same key here, means same account here and here. And that's where the issue comes in. If those two accounts are the same, we're in double trouble. That's why I called it that. And if you're interested in the Solana Dev course, duplicate multiple accounts is the lesson that deals with what we're discussing today. That's the issue. And James has some example with a rock, paper, scissors, where there's two accounts with some player state, which come down to the same thing. But I actually like my example much better, because this is passed in as instruction data. I like my random numbers. Anyway, so let's go through it in our example, because who cares about the dev course? I do. Great resource to learn, by the way. But coming back here. So why is it a problem that the player 1 and the player 2 account are the same? What's going to happen? Well, let's look at the code. So we are getting 2 random numbers, and then we're doing what? Yes, storing them in 2 accounts. However, if this is the same as this, then it would be the same as if I would have written this. And we see what the issue here is. It's obviously that the lucky number is overwritten with the second value. And then, even more importantly, what we're doing here is we're comparing player 1 against himself. I didn't actually write that there, but that's what it would look like, right? I mean, that's essentially what's standing here. Player 1 account, larger player 1 account, which will be false. So this will always be false. So actually player 2 will always win. But it doesn't really matter because winner and loser is always the same guy anyway. So why did I make it so complicated with these random numbers? I don't know. It doesn't matter. It really doesn't matter who wins because both the winner and the loser is always the same account. But then we get to this part that distributes the points. I mean, I could have, of course, written winner points plus equals those and then set the loser points to 0, which would have resulted in the points being 0 always. Because remember, if the loser is the same as the winner, then the last thing that happens is what's persisted. That's why I stored this temporarily here in this other variable, such that it can be assigned here. So, I mean, yeah, badly written code from my side. I could have done that more efficiently and not allowed that sort of exploit. But hey, I mean, it's not like it's unlikely for people to write this code. I mean, did you see me write this code and be like, you can't do it like that. Why is he doing it like that? No, you didn't, did you? It was just, it's like that. You believe me that that's how I would have written the code. Even though I thought about it before, that I need to do it exactly that way that the exploit works. But it can happen that that code is written like that. That is plausible. Also there, other things that can go wrong. This is just one example of why this duplicate mutable account is a problem. So in the end, the winner points will actually be the previous winner points, just a fourth of them, but still the winner points plus, so my own points, plus 100. Then I temporarily set them to 0, but we don't care because then we set it to the winner points again. So we get 0 plus that. Admittedly, we first set them to 0, so we just get a fourth every time because of that plus. It would have been worse if I would have implemented it like this, that I say the winner points are actually the previous winner points plus a fourth of the loser points plus 100 and then set it like this. Then you would get points even faster. And I mean, let's be honest, if I would have written it like this, yeah, then you might have been like, why do you do that so complicated by calculating that first and then set it down here? Maybe you would have. Maybe you wouldn't have. Who knows? Let's store that as even more unfortunate implementation. But we're not gonna use it. Or are we? Yeah, now I committed it. It's in production. Yeah, so let's use this unfortunate implementation. Because it is the same, like it is logically the exact same as what I had before. I just removed the plus here and then put that up there. So it is the same as before. Unless, of course, the loser is equal to the winner. Deploy this, please. So player 1 had 168 points and then player 2 won. So he got 142. It's always just at the 100 level. You get 100 plus a bit of what the other guy had. You never really get higher, because to get higher you really need a streak. Oh cool, see? 200. So that's the usual way. But let's actually hack this. The hack is pretty much the same thing as my test, except we are going to provide the same public key for player 1 and player 2. That's all. That you literally need to change one line. No, one character in my script, and suddenly you're a hacker. That's how it goes. And then also we don't need the signer because we already provide the signature for this one. So it's all good. Let's hack it. So we're hacking as player 1. Look at that signature. That's a hack. Triple X. Oh, no, that was a normal. That wasn't even a hack. That's just a normal game. Because I started the normal test script. What I wanted to start was my hack. Hack it. But the transaction signature still was pretty nice, must admit. All right, the transaction signature is not as nice, but check this out. We now have player 1 and player 2. Surprisingly, the same amount of points. Oh, and then the winner points are 300. So player 1 gets 300 and player 2 gets 0. Now that is actually interesting why player 2 is 0. I would have expected to also say 300. But potentially Anchor will only persist that at the very end. Oh, wow. If that's the case, then I wouldn't even have to do it that weirdly. I spend so much brain capacity on thinking of that, but maybe it could even be simpler. Let me try that after we played a few hacks. First, let's hack again and see if I actually have the 300 now, or if it was overwritten with a 0. I'm actually curious. No! We lost all our points. Uh-oh. Okay. Good, I had a wrong assumption. I admit I had a wrong assumption. I thought that that's how Anchor persists it by the last time it's written. But no, it does not. If this is not persisted mid-runtime, like mid-execution, as I expected it to be, then this and this is actually in memory two different things. So turns out my example is not that great after all. So really, I didn't win anything with that. But I hope that I still teach you something. That's what it's all about. Ugh. I thought I had such a great idea, but apparently I didn't. And then I made you try it out and you were like, oh, this doesn't work, nothing works. I'm just gonna watch the video. Oh, it just really doesn't work. Welcome to my life. That's how I experience it often. So what I learned is that those are still two different things in memory, even though they will then be mapped to the same account. Which also means that only player 2 will ever be persisted, I think. Why do I think that? Because the player 2 is, so that account is after that account, and I guess it's serializing, so storing it onto the account in order at the end of the instruction, I guess, somewhere. Because Anchor abstracts that away for us. We don't need to deserialize and serialize. In a native Rust program, we would know exactly what would happen. But good, that fixes our assumptions about Anchor. Now we know that in memory it's still two different things, but only in the end, player 2 account is serialized. I mean, both of them are serialized, but first this one and then it's overwritten by this one. To check if that's actually true, let's see, because for now we always had 0, 0, 0. Let's see if those 100 actually make it into the next round. Yes, they do. So I guess it really is like that only player 2. Fuck. Well, then my example is a bit shitty. Yeah, I worked on the wrong assumptions. Happens sometimes, but we learned something. It's still a good example. I refuse to let you tell me that what I came up with is shit. Okay, here's what we're gonna do. We're gonna split it into two instructions. That's what we're gonna do. Yes. So the play is just gonna store the lucky numbers. That's what they need to sign for. And then we're going to do a evaluate, which then does all of that stuff. We can literally use the same accounts because it makes it easier. We just use the same accounts. And we split it into a play and then the evaluate, which distributes the points. So we changed the program a little bit. Gonna put both of those instructions into one transaction. So let's run the normal test again, a normal game. Let's see if that works. Again, we didn't change much. It's just two instructions now that have to be in the same transaction. Fallback functions are not supported. Oh, I didn't deploy it. My bad. I didn't deploy it. Deploy this. Here we go. Let's play. Both of them are 0. And we calculate the things and then we evaluate and player 2 has won. Then we're going to play it again. There we go. Player 1 has won this time. And he took a quarter of player 2's points and has 125 now. Still works like a charm. No apparent reason. Now that I warned you in the past that something in the program has changed, and now that you know why it has changed, let's actually try if that now actually lets us properly hack it. So let's also change our hack the same way as our test, do the same thing as in our test, except that we just provide that one key pair and we don't need to sign with the other key pair, and we especially don't need to provide that other key pair here. That's our hack. Hack it! And see what comes up here. Because if we have it in two instructions, now, after the first instruction, the state will hopefully be persisted, such that hopefully always player 2 wins, and then always player 2 gets the points, and then always player 2 is also persisted. Because if player 1 wins, then still player 2 is persisted and he gets 0 points, although it's the same account. But anyway, so player 2 has won. That's what I expect. I could have printed the random numbers as well, but they should now be the same. So the evaluate will always make player 2 win because it will always be the same random number. It doesn't even matter which one, but it's the same. And therefore the larger will always be false, because if they're equal, then it's not larger. So it's always I can show you in the code what I mean. This will always be false because two equal numbers, one will never be larger than the other. So it will always be a player 2 win. And then it will always be the player 2 who gets those points. And then it will always be the player 2 account that gets persisted, even though that is the same account. That also gets persisted first, but then overwritten with the other account. Let's run it one or two more times to see how easy it is to get points with this hack. Oh, that's a nice number. 256. And now 420. Those are great numbers. Yeah, I like them. Next up, we have 625. Not such a nice number, but number go up. Number only go up from now on. 881. One more time and then we reach the 1000. There we go. 1201. We won! Yay! We hacked it. High score. With playing other people, you will never get those high values, I tell you. But now to my actually. Actually, this weirdly written code here. Actually, I literally don't need to do it that complicatedly. I could have, as any normal programmer would, done it like this. Why? Because it's only persisted after the instruction ends anyway. So now wait, let me do a plus equals here as well to make it even cleaner, as any normal programmer would do it. Even if I do this, the winner will still get the points. So even with that implementation, I don't even need to do it that complicatedly, that weirdly as I did it before. Even like this, our hack would work. But I went through the mental challenge of coming up with some code where it would also work if it was immediately persisted onto the account as well. And I had that assumption, that's why I had to move it to a different instruction. But you were here for the process. You totally understand what I did here, right? Otherwise, you can, of course, always ask questions down below or on Twitter or on my Discord. Let's prove that it actually also works if the program was built like this. There we go. Even in that version of the program, I can perform my hack and I will get points. How many points will I get? a quarter of 400 plus 1,200 is 1,600 points. Yeah, 1,601. My head calculation was way slower than this, right? But at least I understand what's happening. Nice. Cool. I like this. And it's barely 3 a.m. We made it. Good to finally finish a video again. One more, because a fourth of that is 400 plus 1 is 500. So that's 2,101 points now. This time I was faster. Look, Mom, I'm faster than blockchain. There we go. 2,101, as I said. Yeah, good. Okay, we leave it. Let's leave it. Oh, wait, no, but we're not done yet. No, we're not done yet. Because obviously we need to discuss how do we fix that? Students, does anybody have an idea how to fix that? Yeah, you in the first row, in front of your screen? Yeah? Tell me. Okay? And why does it fix it? That's right. Exactly. Yeah, so for everybody, I'm so stupid. As our colleague here said, we need to make sure that player 1 is not the same address as player 2. Really, we could also just make sure that player 1 account is not player 2 account, but since those are derived from them, we could also put the constraint here. It doesn't matter where we put the constraint. If we put it here or here, it will fail in any case. I would personally just put it here. So Anchor has those nice constraints where we just say this must be true, and what we say is player 1 dot key must not be the same as player 2 dot key. I think that's all we need. That builds, so let's deploy it. Then try our hack again. Now I would expect an anchor constraint violation. Ha! Hello, constraint violation. Anchor error caused by account player 1 error code. Constraint raw. It's a raw constraint that we are violating here. Because this is a raw constraint. We just say this is a constraint. It's not a specific like has one. By the way, if we didn't use PDAs here, then we would probably want to do something like has one and then match the player. Oh, actually we can't do that because here we call it player 1 and here we call it player. But we could do a more general raw constraint that the player is equal to player 1 dot key, player 1 account dot player. I would need to do something like that, but we don't need to do that since our PDA is making sure of that anyway. We can't put anything else here, and the seeds are checked. But yeah, in general, you would want to also do those kind of checks, but that's a topic for another hack. So in our solution, really, this is the important part. We could put that constraint on those accounts, like we don't need it here, and we can just compare the player 1 account should not equal the player 2 account. But again, since those are PDAs and we make sure that those two are different, then those two will also be different. They are PDAs and those keys are used in the derivation. That's a relevant part here. They can still be the same if the key is not used. You get it. You get what I'm saying. That little thing, that little line here, that constraint check helps us avoid those weird issues when we provide the same account. So now we actually need two different signers. And again, as mentioned, this is just one example of stuff that can go wrong when you allow 2 times the same account to be passed in here. In the accounts, weird stuff can happen. And basically, you want to check that all of the accounts are different. If you have the assumption that they are different accounts, put that assumption into an actual line of code and check that they're different. If you're in native Rust, from the account info.key, you check that the keys are different. Oh well, you check that they're the same and then throw an error, raise an error, whatever. Return an error. I don't care, I'm tired. Oh, it's 3 a.m. Good time to finish. Yeah, but that's it. You gotta check that the accounts are different. Otherwise, weird behavior might happen. I can't tell you, like, this is one of those things that's so, we don't know what happens if we put in the same account here. You have to think through it, and but this one is a really non-obvious thing. And like, because it's so hard to expect that, like, right? That attack, like, you don't think of that. Like a missing owner check or a missing signer check or weird PDA seeds. I would be like, yeah, okay, that's just good practice to always put something here to not have accounts overlap and stuff. Yeah, okay, whatever. But with stuff like that, I mean, I called it player 1 and player 2. They are different. Well, a hacker might disagree. You know what I'm saying? It's a very abstract one, and I really wanted you to be aware of that's a thing that people can just do. They can plug in the same account. If you don't do more checks, like make sure that it's one specific program or whatever. Like with PDAs, basically already make sure that it's a certain account that can't really be faked. But still our assumption is that those two are different, which in our case they were not. And also here, like anybody could put in anything here. This is very unsafe, but at least I did the check. I did the check here that it's a certain key, a sysvar. So that would result in an error if I provided anything else. And I'm pretty sure you could do that here differently. Anchor probably supports the sysvars, but I was too lazy to actually look it up. Okay, good. I think I want to finish. Coming back here, where I started. It has been a hell of a day. A lot of ups and downs. I hope it was as interesting for you as it was for me. I certainly learned a lot about Anchor, and I can make better assumptions for next time, which is always great. You do want to learn, keep improving, and be aware of things that can go wrong. I will never get over the dependency thingies. That's just that where you need to downgrade that, upgrade that version, just with this version, and then use those combinations. And otherwise, you get weird errors that nobody can explain where they even come from. But that's not the topic of today's video. I tried to cut most of that out because it was literally like 2 hours of me just being frustrated. But yeah, I hope that you learned something about double trouble. In other words, what can go wrong if an attacker just plugs in twice the same account and you don't check for that and you expect it to be different accounts, and then you work with them as if they were different accounts, but they're the same account, and then weird stuff happens. Yeah, just wanted to be aware of that. That's if that's all you take away, then cool. Also, we learned when Anchor serializes. I mean, it's great. I mean, so many things that we learned today. It's so cool. I enjoyed it. I hope you had fun. Well, first, I hope that you made Anchor build and you were able to play with it yourself. Actually, well, I mean, if you want to, I can put that on devnet for you. Would that help? Then you don't need to build Anchor yourself. Hold on. You can look at the source code, but if you want to hack it, I put it on devnet for you. Deployed it for you on devnet. You're welcome. But still, if you develop in Anchor or Rust or anywhere, I hope that you don't run into those dependency issues. It has been quite an annoying thing. And I know that Jacob and team is working on that hardcore. That's their top priority, they told me. In the future, that is going to get better. I trust in them. I trust in Solana devs, and eventually we will figure this out. But right now it's a bit of a complicated phase, it seems. Anyway, point is security. Security is important. I want you to learn as much about it as possible, and that's why I'm making this series, and I hope that the series is fun and educational. And I'll see you in the next one, because I love to make them. You can check out those videos, like and subscribe, as always. You know the deal. You know the drill. You know how it is. I like to plug my own shit. Follow me on Twitter. I am getting tired now. I mean, it is past 3 in the morning or at night. I don't know. Anyway, I'm getting tired. I better go. And you learn about security. I wish you all the best for your Solana development journey. GN. Good night.